In this video, we will generate the trend line and dataset of the hyperbolic sine. We begin with the hyperbolic sine, so array formula, hyperbolic sine of the x values, negative 2.8 to positive 2.8. And the infinite product series of the hyperbolic sine, which is equal to x times infinite product of 1 plus x squared over pi squared n squared, where the value n is from 0 to infinity. So we can start from 1 to infinity. We can start with 1 up to infinity. 9 is good enough. Next, the formula, which is equal to array formula of the x values of 1 plus, that's 1 plus x squared. So x raised to the power 2. That's x squared. And divided by, that is pi n squared. So the quantity pi times n. This is our n. Both of them raised to the power 2, while x is raised to the power 2. So that is 1 plus x squared divided by pi squared n squared. So pi n, the quantity squared. And enter. Now we can calculate the infinite product, which is equal to, that is x times the product of these values. Then enter. And we drag this downward. And we'll chart this. So insert chart. And we use scatter chart. Column A is labeled, row 1 is header. We show the trend line. From the series, we show the trend line. The type, polynomial. The degree, we use the 10 degree. Let's try 8 degree. And for the label, we use the equation. Now here's the trend line and polynomial from the infinite product series. So let's verify. So the coefficients, the polynomial regression coefficients, are almost the same. Their trend line almost collinear. There's an error here on both ends because we only limit to 9. We can reduce the error by increasing this to infinity or higher than 9. This completes the use of product in the infinite product series of the hyperbolic sine.